Okay, here we're going to be looking at factoring the difference of squares. Factoring our difference of squares. So our objective today says, hey, I can factor a polynomial that is a difference of squares. Well, what are squares? Well, squares are numbers such as the number 4. The number 4 is a perfect square because if I take the square root of 4, that gives me 2. A nice, pretty integer. This is what we call a perfect square. And there are a lot of perfect squares. We have 4, 9, 16, 25, 36, 49, 64, and so on and so on. Keeps going. But I don't know perfect squares yet, so let's figure it out. So we do know how to go and factor using our A, C, and B process. Oh, but my equation here, I'm missing the B. So this would really be like x squared plus 0x minus 9. And so my AC would be 1 times negative 9, or negative 9. And my B would be 0. So I got to find what can I multiply to get negative 9 but add to get 0. Well, if I did 1 times negative 9, that gives me negative 8. If I did negative 1 times 9, that would give me a positive 8. If I did negative 3 times positive 3, that would give me 0. There's our winner. So I'm going to break this thing apart here. So this piece gets split apart. So I have x squared minus 3x plus 3x minus 9. Doing my factoring by grouping. So out of the first two right here, I would pull out x. This leaves me with x minus 3. Out of this second group here, I would look at it and pull out a 3. So a plus 3, which leaves me with x minus 3. These two pieces are the same. So I take out x minus 3, and I'm left with x plus 3. Wow, that's kind of cool. But our difference of squares, all we have to do is recognize this one's a perfect square and this one's a perfect square. If you see that those are both perfect squares, we don't need to go through and do all of this here. If we had to and forgot, we could. But I look at this and go, man, I got perfect square minus perfect square. I'm going to drop down and put 2 sets of parentheses. In the first blank of parentheses, I put the square root of a squared. Well, the square root of a squared is a. So I'm going to put a here and a right here. And then in the second, the back side of my parentheses, I'm going to put the square root of b squared, which that is b. I put a b here and a b here. And then I'm going to drop in 1 plus, 1 minus. And Bob's your uncle. Difference of squares. Awesome. So now we just have to make sure we figure out which ones are perfect squares. So let's look at example number 1 we got right here. X squared, anytime you have a variable that's an even numbered variable, exponent for the variable, then that is a perfect square. So that one is 49. 49, that's 7 times 7. Perfect square. Drop down with 2 sets of parentheses, the square root of x squared. I put x, I put x. Square root of 49, that was 7 we said, 7 and 7. And then I put a plus, I put a minus, and stick a fork in this bad boy because he is now done. Now, looking at example number 2 right here, we have 25 x squared So 25x squared minus 4. 25 is a perfect square because that's 5 times 5 with the x squared. 4 is a perfect square, so I drop these bad boys down. Put a 5x, 5x, put a dose, a plus, a minus, and he is now done. Difference of perfect squares. Looking here at another example, we have a perfect square here that is 36x squared, and then a perfect square here, 49y squared. So I'm going to drop down and put my two sets of parentheses. Square root of 36x squared is 6x, and I put that at the front side. Square root of 49y squared is 7y, so I put those on the back side. And again, put a plus and a minus. And that has now been factored. At any time, you can always check these by going back and using either FOIL or the box method or whatever you choose to multiply, and check and make sure it works. Now with this example right here, we got to remember our first thing that we have to do is always remove our GCF, the greatest common factor. And in this case, it's going to be 3x squared. So when I do that, I take 3x squared out, which leaves me with x squared minus 9. Notice the piece that's left over now is a difference of perfect squares. So my 3x squared is still chilling out front. We can't just throw it away. It stays there. I put my two sets of parentheses to factor my difference of squares, and I get x and 3, x and 3, put my plus and minus, and now it has been factored completely. Factoring with difference of squares. It's a good idea if you can't remember them. Go through and write your squares all the way up to, I would do at least up to 20. It will make your life easier. So 1 squared is 1, 2 squared is 4, so on and so forth, all the way up to 20 squared, which is 400. Doing this and keeping a list on the side will help make factoring difference of squares that much easier. Enjoy!